Hello friends, you may have seen these visualizations. These are called as heat maps. And it's intuitive that just like distribution of heat, these maps show where values have higher magnitude and where values have less magnitude. And if you analytically observe this data, you can see that here values have higher magnitude, here values have a higher magnitude, and where light color is there, values have less magnitude. Welcome to this session of using R for data visualization, GGplot2, and we are visualizing correlation. In previous sessions, we learned to visualize correlation using scatter plot, using correlograms, using correlation plots uh, with GGLI package. In this session, we are going to learn about heat maps. As I said earlier, heat maps are very good to visualize large numerical data. Heat map shows magnitude of value by using intensity or hue of color. Here you can see that dark color represent large magnitude and light color represent less magnitude. There are two types of heat maps. One type is called as cluster heat map and other is spatial heat map. In cluster heat map, the values are arranged to show their relatedness. But in spatial heat map, the location of the value is kept intact. We can see at which location higher magnitude is there and in which location lower magnitude is there. We are in R Studio and I will make this script available to you for your practice. First, we will see what is the help provided by R for the function heatmap. When we run this command question mark heatmap, we will get the help, and this is help here. Heatmap function draws a heatmap. You can read the description to know more about heatmap. I will skip this point. As usual, I have set my working directory. I have tested whether working directory is set correctly or not. It's set correctly. We are going to plot data from iris dataset. An iris dataset has 4 numerical variables and 1 categorical variable. It's very important to remember that heat map require data in matrix format. Therefore, to convert this iris data frame in matrix form, we have used this command. Data is equal to as.matrix in bracket iris and in square bracket comma followed by -5. Here, before comma, we can have our row numbers, but to select all the rows we have kept it blank, and after that this number represent the number of column or index of column. Spaces column is the fifth column, therefore we kept it fifth, and -5 indicate that we have to remove that column. I will run this. If we see head of data whether it got converted to matrix or not, we will run this. Look here, this has got converted to matrix because in data frame, row numbers are defined like this without any square bracket, but in matrix, you will see this type of index numbering. To get heatmap, in base R, heatmap function is there. And this heatmap function takes the argument data. I will run this and we have got the heatmap. We can see that intensity of this length is very high, intensity of this width is less, and here different distributions of intensities are there. But these column names are not completely visible. We will change its size. For that, we will add this argument, that is Cx column is equal to 0.9, and this Cx column changes the size of this, and this size will specify by this relative number 0.9. And look here, that size has got changed. The sepal length has high intensity, petal width has low intensity, and in sepal width and petal length these different intensities are there. If you look carefully at this heat map, intensity of sepal length is very high as compared to these three columns. This is because sepal length very large as compared to petal width and other two variables. Heat map provides an argument scale, and here we have applied that scaling to column to regularize these values as per the columns. We will run this. Now variations across the columns have been made similar and the graph is more informative. This is cluster heat map. In this, observations are arranged to make their clusters. Here those clusters are visible. If we see here, the sequence is different: 53, 79, 86, 114. This is not the actual sequence of observations. To remove these dendrograms, in heat map, we can have the argument call values is equal to NA. To remove this column dendrogram and row values NA to remove this row dendrogram. We'll run this code. Column dendrogram disappeared. We'll remove the row dendrogram disappeared, and we will remove both these using col value is equal to NA and row value is equal to NA. I will run this, and both dendrograms got disappeared. And if you look, this sequence is the actual sequence of observations 1 to 146, that is 150 here. And here the column variables are also as per their actual sequence in the data, that is sepal length, sepal width, petal length and petal width. This color scheme you can change, and here we will see how to manage that color scheme. And for that we have used this argument, that is col is equal to cm.colors 256. We will run this. This different color scheme is there, where this purple color is for large intensity and this sky blue color is for low intensity. And this is using this color scheme cm.colors is equal to 256. In our parlance, this is called as color palette. Here we will use different color palette, that is color is equal to terrain colors dot 56. I will run this. These different colors are there, where green shows the low intensity and these other colors are showing the higher intensity. We can use our color brewer also, and we will have different video for our color brewer, but I will show how this code works. Here we have to load the library R color brewer. I will load this. Library has been loaded, and this object custom color is defined as color ramp palette. In bracket arguments are brewer.pal and in again bracket 8 comma piyg, and here we want 25 colors, therefore in bracket this 25 will define the 25 different colors. I will run this. We have got the color palette. Now in heatmap argument we will use this color is equal to custom.color. This color object is the color palette. I will run this. A different color is there, more impressive as compared to earlier color schemes. Here the column names are very large. I will use the argument cxcol is equal to 0.9 as earlier to make these column names completely visible. And that's all for heatmap. I have given the link of this script in description. Please try that to learn more about this type of visualization. If you have liked this video, please click the like button. Your likes will bring this up in search result, and subscribe to my channel. Share this video with your friends. If you want notifications of my next video, please press the bell icon. Thank you.